Hello, Greener Summit. Are you excited?
Yes.
Yay! Ready for the panel? Okay, I see that you are totally loving this AI stuff, right? This is the reason why you got here so early and everything. But yeah, welcome. My name is Martin Goroško. I'm the head of Science and Business Park Technopol. And today I'm going to moderate this quick session about the AI and how we can actually implement AI in industry in order to meet the green transformation goals. It's rather ambitious goals because currently we are mostly talking about the digitalization of the industry. AI for me represents the absolutely next level of that. But in order to cover this topic, I have 4 wonderful speakers here, and we have like a very good mix and variety at the stage actually. We have public sector representative, we have the manufacturing company, we do have a tech company, and we do have a cluster. And they are all having first-hand experiences how to implement this AI and how this could make the world a better place, right? And the session setup today is going to be rather simple. The panelists are going to introduce themselves. We're going to have 7-minute slide text for each and every one of them. So they are going to open up their perspective, so you have all the background information you are going to need. And after that, we're going to have a brief discussion over the topic. So if you're ready, then without further ado, I would like to give the word to our first panelist and first presenter as well. Siim Kinnas, Enterprise Estonia. The floor is absolutely yours.
Okay.
Kick it off.
Thank you. So, hi, my name is Siim Kinnas. I'm the team lead for Enterprise Estonia's Technology Transfer Unit. And one of the things that we do at the Technology Transfer Unit is actually we try to find out what the stories are that data tells us about technology. And one of the stories that we are being told today is about AI, and it has been told so well, for example, by Shahab here, that I am absolutely going to be ignoring it. Because AI is by now is not in the future, it is here already. It is a design language already. The same way as elevators made it possible to build high-rises, and now no one thinks about elevators as technology. No, it's just there, it just works. Same with AI, same with machine learning. So I'm going to absolutely ignore it in the next talk. So these beautiful colored lines behind me represent the number of patents that were taken for each and every technology area that is considered to be aiding in the mitigation of the results and challenges of climate change. And we see that on the right-hand side, from top to bottom, there's photovoltaics, there's internal combustion engines, there's fuel cells, high-level solutions, I will come to that, space heating and recycling. This is only the top 6 of the technologies. And notice AI is nowhere to be seen. Where AI is likely to be seen is the high-level technologies. In the top corner there, you can see from 2019 to 2020, it has been rising quite a bit. And that is actually a symptom of AI being used in every one of those other technologies as an enabling technology, as a way to make them actually work. So I'm not going into the bump in the photovoltaics, but I would rather have you focus on the bottom 2 curves of space heating and recycling technologies. You can see those lines in patenting have been completely stagnant for the past 20 years and are only rising in the past few years. That is specifically due to AI and machine-assisted learning, in the sense that those operations and those activities that are necessary for recycling and room heating are now becoming AI-enabled, in the sense that they are becoming intelligent. And one of the things that those high-level solutions, with this really odd little sickly green line going up there, they actually tell things about, for example, how best to direct traffic, how best to use data, how to heat buildings, and so on and so forth. So it's an enabling technology. Another thing that why internal combustion engines is there, just to show you that basically the line of number of patents actually also tells us how much of innovation is happening in that space and how much investment is going into that technology space. And we can see that the combustion engines is basically starting to plummet. So the time is now. Electricity is the future. Where does new tech come from? Geographically, well, no surprise there. The highest source is the US for green techs, but Japan and Korea are close seconds. I would also like to point out the orange line coming from 2016 thereabouts, starting to rise and coming to 15,000 patents in 2020. This is China. And these are not patents and technologies created in China, but these are companies patenting in China. Patenting from China is actually an order of magnitude even higher. I just left it out from this graph here, which means that China is becoming more and more important for companies to take into account when they are building their business strategies. So where do the big kids play? These are the top 10 companies in the climate change mitigation technology areas. See any startups there? No? Surprise, surprise. These are all big multinationals, and the size of the bubble actually shows you how much money that company is putting into research into that technology areas. And you can see that, for example, Toyota has made a very strategic choice in its strategic areas. It is still putting quite a lot of money into internal combustion engines, but it's, this is not a dynamic graph. It is dropping quite a lot more heavily than you saw in the previous graph that I showed you there. The other big chemistry companies and technology companies are sort of hedging their bets between things, but it is always horizontal. A good indicator about technology penetration is licensing deal counts. And we can see that licensing deals are being raised. The number of licensing deals is becoming more and more each year. And there is a slight time lag in the graph there because we don't have complete data yet on 21 and 22. But about 1,000 licensing deals are being performed each year, which means that combined with the information from the first slide where we saw those flat lines, which means that those technologies are ready now for licensing, they are also ready from the amount that they are already being licensed. So if you have in your company some sort of technology that is necessary to reach your goal, but is not core to what you are developing, it might make sense to actually not develop that technology on your own, but just license it in from somewhere else. Chances are pretty high that that technology already exists. Also, what exists is litigation activity. So this is the number of patent lawsuits in the realm of climate change mitigation technologies. And you can see that this is rising quite heavily, which means that if you're operating in that space and if you are thinking about international business, chances are that you are infringing on someone's patents already, which means that you are going to get sued, which means that it is no longer possible to operate on the premises, oh, we are small and so fast, we don't need patents anymore, we just gonna innovate our way away from everyone else. Did you see that there's been like thousands of patents each year? You really think you're going to be past everyone? Not likely. So freedom to operate is the name of the game here. So to address the elephant in the room, just in case, hydrogen is a special case in the sense that we did not see hydrogen technology on the first slide, did we? We only saw fuel cells. We are already pretty good at burning hydrogen and making electricity out of hydrogen, but we are not very good at moving hydrogen about and creating hydrogen, sort of producing hydrogen on an industrial level. So what those graphs show you is the blue graph is the number of patents in the realm of battery technology. And the red line is the number of patents in hydrogen production technology. And what it tells us, with the help of the next two slides, is that hydrogen technology is now where it was, where battery technology was 15 years ago. So it is on the brink of disruption. So if you're looking for a business opportunity to really have an effect on the green future, hydrogen technology, probably combined with some sort of machine learning or AI, is where it's at. Why I'm confident in saying that? So for example, this is the amount of peer-reviewed papers being published each year. It is on the rise and quite heavily. Also, VC investments are, well, quite obvious. So the main conclusions. Green tech is not the future. It is here, it has been here at least for the past 10 years. It's up to you and us to actually sort of get to it and put it into use. Good enough plug-and-play technologies already exist. There is no point in spending time, money, and effort in developing adjunct technologies to your own core competences. Focus on your core, license in everything else. So this is the open innovation model. This is the way that we can get ahead, actually, of the whole world here in Estonia. And if you are developing tech, keep in mind, so is the competition. And the competition is ahead of you, probably, in the sense that they have protected IP, and they will be coming for you, as we saw from the legal data. So get your IP in order. And the great promised land of the future seems to be hydrogen at the moment. So now is the time to invest in that, which luckily we are as a country. So if you want an analysis like this, we also do that as a service for companies. Scan the QR or just write to me. I would be happy to help. Cheers.
Thank you, Siim, for the
So
insight.
how am I with time?
You basically went over time, but it's obvious. But anyways, thank you for that. Thank you for sharing. So next up, we're actually going to hear the perspective from the startup company. And I'm really glad and honored to introduce one of my favorite ones in the area. It's called Fractory. You probably have heard about them, right? Who knows about Fractory? Who have used Fractory, the solution, the software, the platform?
There's two.
Wow, that's too bad. But anyways, Fractory is innovating the industry as well. They have worked with, I guess, hundreds and hundreds of industry companies. And I'm really glad to introduce Joosep Merelaht, the co-founder and the COO of Fractory. And we are really excited to hear your perspective. The floor is yours.
Cheers. Should I sit or should I stand?
Stand is better. Everybody
Stand
can
is
see
better
you.
because
and
you
you
can
have
see
a fancy
sweater
as
back,
well.
so be aware.
Branded.
Sweaters. That's cool. All right, I'll go back. Thank you, Martin. I'm Joosep, co-founder of Fractory, and every day I'm dealing with sales and operations. And here today, to briefly sort of talk about the perspective of a tech company. So Siim already told you about the fancy billions spent on machine learning and AI. We are trying to do it with much less money and in a different way as well, a bit. But Fractory is a cloud manufacturing platform that connects engineering companies to manufacturing companies. So engineers, production managers, purchasing managers can access a wide range of different manufacturing methods by just simply uploading their CAD files. Our system, our smart algorithms will then choose the best suited manufacturer for this particular project based on all the different parameters the client needs. And then the parts are produced. So as you understand, metal is everywhere. If you look around today, the ceiling, the construction, the chairs, the furniture is everywhere. And if there's a company producing something, then they pretty much always do also some kind of an outsourcing process. Some components are made outside of their own factory. And that's where the problem starts. Companies are good at communicating inside of the company, but when it comes down to buying something from outside of the factory, then you have to send emails, make phone calls, get quotes, and it wastes your time. So there's lots of resource which is managed poorly. And this is also where Fractory was born. Back in 2017, my co-founder Martin was working as a mechanical engineer. He was ordering parts constantly every day, struggling to get answers, struggling to get anything sort of meaningful happening. And we thought that, okay, there is potential in the market to make it better. So the why Fractory exists, is on the screen right now. We are guiding manufacturing to become more sustainable. And this is not only about the green topics or the environmental sustainability, which actually also includes, we reduce the use of material, the use of scrap, we produce closer, we aggregate orders. But it's also about two other topics, what we have defined as a company, as a tech company, that we have an impact in. This is social and economic sustainability. Social sustainability is something which we take really seriously. It's about having more engineers in the world, pretty much. Engineering as such is a pretty difficult topic to study. Lots of math, physics, all the other things. But let's be honest, to have a happier life, a better future, civil engineers, design engineers, software engineers, mechanical engineers are the people who actually will figure out the solutions, the products, essentially. So we need to promote engineering as such. We need people who understand the drawing like this and who can create a drawing like that as well. And the same lack of engineers actually comes down to economic sustainability as well. So this is a pretty typical example of somebody asking for a request for quote from some other company or outsourcing. You have 100 parts, you want to get them made. So you ask for a quote. Let's say in this case, there's 3 different companies. All of these companies have taught the engineers, draftsmen, estimators, trying to figure out the price. Some have some better softwares, some are still using pen and paper. Hours are spent, only one company will win. I'd say that the time spent for the other engineers is not the time well spent. And the other part of economic sustainability is the machinery idle time. Studies say that around 50% of machines are sitting idle at any given time in outsourcing. Meaning that actually there are machinery on the market that can produce stuff, but they are not just found. Either they're on the 50th page of Google, or you don't trust them, or you don't know them, or whatever else, they're not qualified for yourself as a valid supplier. And this is where Fractory helps as well. And then as you understand how we do it, like how we help the why, is by finding efficiencies, accessibility, and providing quality for the manufacturing industry. And then what we do is the obvious thing, what I mentioned in the beginning as well. We provide a cloud manufacturing platform for on-demand manufacturing services. And this is a laser cutter in action, just so you know what we do every day. Cuts out metal, helps companies to make great products. Fractory in a nutshell, we are 5 years old, around 90 people. We work in 2 different continents. We have offices in Chicago, USA, Manchester, UK, also in Finland, Turku, and in Tartu and Tallinn as well. We have grown quite fast, and obviously we are looking for great colleagues to join us as well. So if anyone is interested, let me know. And this is our brief story. Happy to have a chat later on. Thanks.
Yeah, thank you, Josef, for sharing. So moving on, another cool thing about AI is that not only it's beneficial for human beings, but also, for instance, cows can use that, right? It does good for cows. Yeah. And for that specific purpose, I'm really excited to give the floor to Hardi Tamm, who is the CEO of Estonian Dairy Cluster. Yes. And as a cluster, they have practiced the usage of AI as well, which is very astonishing fact for me, because I've always considered that, okay, how difficult it is to handle the cattle and produce the dairy products. But anyways, glad to give the floor now and open up the perspective, Hardi, and say what you are doing.
Thank you, Martin. Hello. As was introduced, our topic actually is food industry, not necessarily the issue where from it starts has been hidden oftenly. Oftenly, if you ask where the food coming, is coming from the shop, isn't it?
Yes.
But it's not necessarily the case. So Estonian Dairy Cluster is NGO of entrepreneurs, which is looking ahead sort of 10 years and trying to solve a few of those challenges if it's in our hands. So, and Wise Cow is one of our childs, which is meant to address the challenges which actually is in the food industry. In our turbulent times, you may all have understood that we need actually food as a first thing, shelter as a second thing, and in our climate, maybe some energy to keep this warm. And these typical issues like shortage in labor force is question how we handle those in animal husbandry, for instance, which is labor intensive. But nobody is asking. You need to be more effective. Consumer demands, which enters into the sector maybe in production plant level, when dairy plant has to describe what is the animal health in the farm. Transition to green economy brings new layers on the picture. But also, one thing is how we make the sector as a whole, from fork or farm, from the fork, more attractive. We need to bring more people into that, even in this labor shortage situation. And in describing my own understanding or belief is I really much prefer prevention as in action to treatment. And this is one of the challenges also Green Turn demands. And describing the problem, animal husbandry and in herds has been historically crucial to hide your weakness out of predators. So discovery of disease is therefore tricky. And you need two things. Experienced staff, and the staff should be present to find it out. And typically, if it's made too late, you will open up several issues you don't want to. And in efficiency side, you need badly this early notice. And prevention is actually critical and unavoidable, actually. But in order to discover, you need to have a small group, but it's costly. So, and a lot of other following issues coming out of it, because pathogens causing like respiratory diseases, for instance, spread more because you didn't find out it in right time. And if you now describe the following wave is, as you have more diseases you would like to, you have a more calves mortality. In the future perspective, you have a less milk yield. You use more drugs you would like to, and not talking anything about animal well-being. That's why we talk about food industry. This is a milk production in Estonian case, for instance, we're #1 in the European level, and I think our farms are like a collective of top sport athletes who are willing to support them also with real supportive things, not just opinions. And our solution, what we have developed together with team Wisecow, is consisting health transmitting implant with sort of 5 millimeters as a diameter and 50 as a length, which active device. Also includes, it will put under the skin. The second layer is gateway system, which gathers the signals and send it to the third component, which is most likely will be the crucial one. This is our iCloud. And different to other systems which are available, we create this 24/7 monitoring system which is continuous from the birth to the death. Typically, this hasn't been the case. Typically, we address only cow as a milking system, but we should cover the part where animal is young. I presume most of you has been facing like holding your own kid or your baby sister or brother and realizing that you can't help. You would like to, but you don't understand. In animal husbandry, these the difference is they never talk. You need to figure out it by yourself. And we are able to give decision support and pre-warning sort of day or two before. Many of you have probably figured out that I feel sort of funny feeling, but now everything's ordered, and now I will be sick a few days later. And this is something that can be arranged only by using big data and artificial intelligence. We are like profiling the situation by combining from all of this data, forming the electronic health passport. So if you look at the tiny graph here, you see the blue line is what implant is measuring. The yellow line is clinical trial rectal temperature. The green line there is artificial intelligence understanding about the real temperature. And the red dots here are this prediction of this is most likely the animal to be sick. And I'm not talking about this long journey you have went through. This is the technological, like designing, drawing, assembling, the second line, all this design of clinical trial to get all of these proved, not opinions, but proved. And so we form out of this knowledge what we measure, also outside, like a temperature, moisture, input layer, all this traditional graph to get these red, what is a warning out of it. So, and in terms of food industries, there is about 1 billion bovines globally. Others animals can be also follow. Even endangered species might be object in order to help them out of this situation when humankind has caused. The monitoring cycle is different. We are able to improve the young stock monitoring, which is very important, increase groups, decrease diseases, mortality, most likely eliminate the disease cases of the groups if we have a responsible owner. Not talking anything about cows, which is similar. So I think what it is we see energy in the body. This is not thermometer under the skin, which is the energy. We see the direction, we profile it, and we translate it into action. So with improved treatment, we increase efficiency, use less trucks, etc., up to the lower carbon footprint, which is calculated. But importantly, also, we will clarify a lot of subjective situation in value chain, also like a transportation stress whatsoever. And with this work, we hope that is our tiny contribution to the future, also to have a food on the table. Thank you.
Wow, that was good. And thank you, Hardi. And last but not least, we're actually going to hear the insight from real manufacturing company as well. And I'm really glad to introduce Marko Lillemets, the CEO of Pentamet. And I'm really glad to see that you have something tangible with you as well. It's straight from the future, I can say, just for the look of that. But anyways, the floor is yours. Tell us what you are doing.
Hello, my name is Marko Lillemets. I'm the CEO of Pentamet. Pentamet manufactures expansion joints to various applications around the world. The purpose of this expansion joint is to absorb movements and vibration. We can design these expansion joints to withstand pressures up to 60 bar and temperatures up to 1200 degrees. It is like an eggshell between heavy constructions that makes them critical for our customers. They're also wearable parts. That means they will be changed periodically, and they are also recyclable parts. So wherever there is a closed piping system, expansion joint is present, whether in a ship, whether in power plant, whether in district heating plant. So our story, in 2016, we attended in Enterprise Estonia organized course called Business Model Practicum. During that, we came up with an idea to digitalize expansion joints. The current methods are very primitive, and the imminent benefit for our system will be to reduce the carbon footprint, to reduce the maintenance cost, to reduce insurance cost, to increase plant safety and reliability, and also, and I think the most important, to reduce or even eliminate the need for unscheduled maintenance. So in 2018, we shook hands with Taltech and started our preliminary study of developing a monitoring system for expansion joints. During this study, we made in-depth analysis for the different failure causes. We studied different internal and external environments. We visited different plants, and the conclusion was that an efficient monitoring system can be developed. So in 2019, we started our proof of concept study for predictive maintenance of expansion joints. A state-of-the-art test bench was built during this project, as you see in the top picture. The purpose of this bench was to test different algorithms and at the same time to gather data. For data gathering, we destroyed a large amount of expansion joints manufactured by us, manufactured by our competitors, with different configuration, different material, different media inside. The reason why we used competitor ones also was that we wanted that our monitoring system could be used also with our competitors' expansion joints. And the final aim of this project was to develop a system that could, let's say, alert operator before expansion joints fails and therefore prevent damage to environment or to material. But since all these plants are so different, even when it's manufactured by one, let's say, EPC company, there is a large difference between one and another, let's say, power plant. So we need something that could be able to learn to understand these conditions when we install our product and when we install our monitoring system. So in this year, we started a project with AI and Robotics Estonia. The purpose of this project was to develop an artificial intelligence-based system that could prevent failures in the production process and let's say, reduce or eliminate the need for unscheduled maintenance. During the project, we again tested different algorithms which will help to adapt to different kind of expansion joints, different kind of materials, different kind of medias inside. And most of all, it would help to understand the system, what are the expansion joint life cycle starting conditions. So we were again very satisfied with this project. We came to an understanding that the market exceeds far beyond the expansion joint market that we were starting with. So basically, wherever there is a need for condition or behavior monitoring, wherever there is a risk of interruption in the production processes, and through that risk to environment or people, or whether there are wearable parts that are changed too often or worse, too late, our monitoring system can be adapted. So as a final word, just I would like to give my appreciation to Aire, to Enterprise Estonia, to Credex, and most of all to our TalTech team. It has been challenging years. The journey is just beginning, and it would have not been possible without them. Thank you.
Yeah, thank you. So now we have heard the background information from each and every panelist here, and I'm really glad to say that we can now move on to the very essence of this stage time here. So it's going to be a discussion panel. Seem, are you excited?
Yes.
That's good. But anyways, I would like to draw your attention back to the very topic of this session. So we were supposed to discuss how AI and digitalization potentially can drive the industry towards the green transformation. I'm kind of having the perspective that in order to implement the AI and to really make the meaningful results out of AI, you really need to have a very good technological background as well in the company, right? Otherwise, it doesn't make sense to jump into AI solutions if you don't have like your data digitalized and so on. In general, how would you see, what is the digitalization level of the industry that you have encountered? Are the companies really ready to take on AI solutions? And maybe this could be like a perfect question for you, to you, Siim, and maybe even to Joosep, because you have seen so many industrial companies so closely. So whoever wants to start off.
Maybe also you go first.
Yeah, sure. I mean, it's a difficult one. There's always this, in the previous presentation, there was this slide regards what's the need, right? What do you need to understand that you have the need? And then what's the sort of like the means to help to resolve it? And if we talk about machine learning or AI, then I think our industry, Marco, sort of let's call it the metal industry and industrial sort of side of it, this is something which still sort of adopts the idea. And it's fairly early on. And I would say Marco's sort of exercises or sort of the studies you do with the university and everything, this is a really, really good example of how this can be done. But many companies, I would say majority, hasn't still, especially in the SME sector, has not still sort of understood the need or the value of it yet. So, if we talk about companies we encounter, they're mostly either outsourcing company suppliers to somebody producing products, or they are engineering companies, and they have different sort of development phases as well. Like some are still trying to get out of Excel, and some are already sort of implemented some ERP systems, some have more advanced systems in place already. It was discussed like factory sort of, I don't know, maintenance, machine maintenance, so on. So I would say the spectrum is quite wide and there's no specific sort of point where you can tell, but in general, we are still in the very early stages.
But if you're talking about if you're onboarding them to your solution and you have the AI component in there, do the companies understand what you are talking about?
We do have an AI component in it, but again, this is not for the main feature, I would say, even, to be honest. Like, for us as well, maybe just to go a bit further, our business started in 2017, and a bit before that, the whole AI thing started to become like, sort of like a mainstream thing. So we have been growing up in the buzzwords of AI and machine learning quite a bit. And these are often used in a way that maybe you can also have other more simple solutions to some problems than utilizing AI or machine learning. And that's what we have followed as well. We do have some components of AI, as for instance, calculating potential shipping volumes and pallet sizes and how things are. But these are really sort of the cases where you really need it, and you have the data as well to back it up. So, yeah.
So
to pick up from this, from Shahab's talk, you actually saw that the main issue with AI and any kind of machine learning is the quality of data that goes into training the models. So that's actually the most important bottleneck in adoption of AI in production, in the sense that companies usually actually start their voyage towards implementing AI in their production through digitalization first. So there are actually a digitalization masterclass that we offer as Enterprise Estonia. There are support measures coming out from the Ministry of Economic Affairs to help companies at least first up assess what it is that they have in-house as sort of capabilities, what they can do first, and sort of build a roadmap from there of where to go and what they need with regard to their business actual goals. So again, from my own talk, I have to say that AI itself is a tool, not a thing to pursue on its own. So the way that the things work usually is that a company would have to get in some source of data that can be put into effective use. Quite often times with production companies, that means that their production machinery needs to be equipped with sensors. Those sensors need to be equipped to data centers so that data needs to be analyzed and so on and so forth, up to the point where it can actually be used as data and input and output and decision making. So for example, we recently visited AMR, the Irish Manufacturing Research Centre in Ireland. For example, there was a really cool project with existing devices that were not AI capable yet, but they added, for example, vibration sensors to those. I think that you would probably do something like that as well, quite possibly. With those vibration sensors, they could actually detect when the spindle of the CNC machine was getting too hot, because it introduced a vibration, for example. And in quite a special case, they tracked down a source of errors in their CNC machine, where from time to time, quite randomly, a CNC machine the spindle would run into the metal and destroy itself. Turns out it was a forklift that drove by that caused this. Start with an assessment of what data we have, put down a roadmap of sensors and data that you can sort of start gathering, and from there build new models and try to go step by step. It's really hard to go all in on AI at once, but the good news is there are service providers out there.
So taking it step by step, right? Mm-hmm. Investing in digitalization and then moving on to more complicated stuff. So
and don't try to do it alone. There are very good professionals out there that help you in doing that.
Don't do it alone, right?
Yeah.
So anyways, moving forward with the implementation part of the AI, I mean, you elaborated a bit on that as well, that you are actually using AI technology. But if I'm talking about like implementation of the AI, then I'm mostly like thinking about the efficiency that is going to be obviously there. You are cutting costs, you are maybe increasing the revenues, maybe you don't need anymore so many people in the manufacturing, right? So those are the goals that you are going after. But what about those green transformation goals? Like, are there some opportunities to associate the digitalization and AI with green transformation in the industry as well? And maybe, yeah, Hardi and Marko, maybe you can share your experience on that. Like if you started off with those digitalization projects, did you really have this green transformation at site at the very moment as well, or it was mostly about the efficiency you wanted to achieve?
Yes, I think the correct answer is digitalization should be first anyway. And efficiency is depending on industry. I think in this food industry has been enough under the pressure continuously. So that has been the trigger of efficiency is there. But now there are a lot of other questions which put the industry onto the decision where shall we invest further? Or will our investments be too complex to quit at all? So I think in this respect, this need is there, the ability, the depth is also there. But now is question how quickly we can produce this data which is necessary to train the AI, because the entrepreneur would rely proven cases. So, and think in my case is you need years to gather data, to profile these different things. If we were describing the health conditions, next is like we profile the drug, how this works in the animal, in the mammal body, literally. Then we talk about stress or next things which hasn't been on the table so far, because we have talking that maybe this causing some stress if you transport animals. But if consumer is not knowing that, or how we should afterwards should aggregate all of the data, which will be just tiny thing on the label. And I think for that we need a lot of thinking, and then maybe AI is helping us to predict a lot of things which we are not able to talk. We talk about, for instance, the animal well-being as something we would like to have. But what it means, really, we don't have any standards on that. And this is something we can't measure, but we can, helped by AI, we can design what the profile should look like and what is the elementary for industry next within 5 years or so. So these predictions, I think, are important to create.
Yeah. Marko, what about you? Do you have like green and sustainability goals in your vision as well, if you design those AI projects or digitalization projects?
When you speak about this project, then you know there is 18,000 power plants around the world. Each of them has around 50 of these expansion joints. I think it's
they are missing one right now.
We are helping others to go green through our product because you know when we reduce these unscheduled shutdowns and we reduce the amount of maintenance that is required, and so it is like that is our contribution at the moment now.
Okay. So taking the helicopter view and again approaching you guys, like if we are talking about the development of AI, then potentially those recent developments in our economy related to the war and the energy crisis and stuff like that, that industry is facing as well. What do you foresee or think? Is the digitalization and implementing AI still at the very focus of the industry, or they have more urgent stuff to consider right now? And then this digitalization and AI is maybe priority number 10, 11, 12. So how do you see that in general, if you take like this very wide helicopter approach on that?
So actually, there's been quite a bit of research on this. I mean, like scientific research. And the most recent thinking seems to be that basically, if you're a company that has not done AI before, in a crisis is not a time to sort of start doing it now. But if you already have some capabilities in that range, sort of already have built something into it, sort of leaning into AI more might actually give you a benefit, but sort of not from a get-go, sort of basically, so not from zero. You have to have a foundation already. Okay,
Josep, how about you? What do you feel? If you discuss things with industrial companies, is digitalization and I don't know, testing and trying new solutions priority right now for them?
I think what Siim mentioned makes sense, and you can see it around as well. And everybody in manufacturing currently, this is kind of a Maslow pyramid thing, right? Where you first is survival, and then sort of thinking other things. And as the trouble is that the example is as well that the benefit is sort of like mid or long term, but not short term. Short term, you're still investing heavily. And if the case is what we have right now, losing business, all the other costs going up, then I would agree with Siim that I think this is the general perception as well. This is just nicely said, and also studies sort of back it up.
Okay, cool. So we have good 2 minutes before the break starts. So I'm going to address the very last questions to you guys. So if we're talking about the future, like you are both representing industry, what do you foresee? What could be like those super trends happening right now or in the nearest future that drive the industry more into implementing AI technology and digitalization, thus through that reaching more to sustainability and green transformation goals? So what do you foresee? What are the trends going to happen anytime soon? So,
I was attending last week in Deepest Spin-off, which is run by Kaisa Hansen from Taltech and Christina Esop from Sunly. So there was an interesting topic regarding the sustainability and these ESGs, and that banks more and more will start to look in business plans this sustainability. And I think that the more they look and the more it will accelerate also investments even to AI. So I think this is maybe one crucial thing that, and one which will rapidly let's say, accelerate this process.
okay, would you like to add something?
I think it's important, this sustainability topic as such, because we have seen that a lot of things which has been like a black and white scale can now be more specific. And I think in the food industry case, what we have seen in Estonia, for instance, is if our top farms are making this carbon dioxide footprint calculation, they can see that, okay, Estonian top farm carbon footprint is lower than like competing soya industry, which is considered or heavily promoted to be somehow sustainable. So it's not necessarily like opinion. We need to prove, and we build this kind of backbone also together with this new sensors or new AI solutions to the industry and help them do their work. Maybe they can then more deal with consumer who actually has much higher levy to push this process on than this traditional investment solution. But we typically say that this can't be done. But if you are able to also share something with consumer, then you may have some hope to direct them to different solutions.
Okay, thank you for that. So we really need to conclude here. So I would like to thank the panel, and I would definitely encourage you to take on this digitalization. You can do that and divide that into smaller steps. So you can work in sprints in order to achieve that. Try to keep in mind that sustainability and green transformation should be part of the quest or the mission and the project as well. And I'm really encouraging you to take this opportunity during the break to approach our fine panelists. So if you would like to have the follow-up discussion with them, then it's a perfect time to do that. But anyways, I hope you enjoyed the panel. I hope you are enjoying the rest of the conference. And I would ask you to give a big hand to our panelists today. Thank you. Well done. Thank you. Thanks. Thank you.